queue using linked list. The implementation is very simple because we have to more or less we have to implement two functions. One is the enqueue function, other one is the dequeue function. Whenever someone is saying that you are given a linked list, it means the head node is given that you know already. So what we will do, we will initially take the head as null. Maybe you can take the tail pointer also to point to the last node. Initially the tail is null. What will happen? We will write two functions here. The first one is enqueue function. The second is nothing but dequeue function. Obviously the enqueue and dequeue function must be implemented in order of one time. So what we will do, please listen. We'll write the function like this: public, let's say static, void enqueue int data, and we'll write the code here. Whenever someone is saying, let's say enqueue 20 or 10, internally what we will do, first we'll create one node here. When we create the node data will be 10 and next pointer is initially null. What we will do, we will insert that particular node at the end of the given linked list. That is nothing but inserting the node at the end of the given linked list is nothing but the enqueue operation. And that is very simple here. What you will do, you will do something like this. Maybe you can first create the node, let's say node equal to new node, and you will put the data here. And then you will insert this particular node at the end of the linked list. You will write something like this. You'll put some condition, maybe if head is null, it means the linked list is empty. Then in that case, you have to update both the head and tail. Then you will just point head equal to node and the tail also equal to node. Otherwise, if this is not the case, then in that case, what you have to do, you will write something like this, because you have to insert the data at the end of the linked list. So you are maintaining one pointer here that is nothing but the tail pointer. So we'll just write tail dot next equal to that particular node, and then update that tail pointer. Now tail pointer will point to the node here. That's it. This is what we have to do when we will insert a new node in the linked list. If you want to take a size variable, maybe initially let's say the size is 0, then at the end of inserting the node, you can just increase the size. Here you can see that we will not put any condition here because we can dynamically increase the size and dynamically decrease the size. There is no restriction as such. This is how we can enqueue a data into the queue using the linked list. Regarding the dequeue operation, what we will do, we'll write the function like this. Let's say public static int dequeue. Obviously, the dequeue means the person or the element which is inserted first will be deleted first. So here you can see that, let's say you are performing enqueue10, then enqueue20, then maybe let's say enqueue30. What will happen initially when you inserted 10, your head is pointing to null. When you insert, your head will point to 1k, maybe it is created at 1k location, and tail will also point to 1k. When you call the enqueue operation, enqueue20, your head is not null, so you will insert after the tail pointer is 1k, 1k dot next is new node. Let's say new node is created at 2k, so we'll put 2k here, and that's it. And update the tail pointer to 2k. Similarly for NQ30, head is not null, you will insert at tail dot next. Tail is nothing but 2k. The new node, let's say it is created at 3k. So we'll just write 3k here and update the tail pointer to 3k. Something like this will happen when you will execute the enqueue operation. Now, when you will do this, you can see the head is 1k and the tail is nothing but equal to 3k. Now, if you want to delete the node, obviously you can see that the node which come first will be deleted first. So here you can see that this particular node is coming first. This particular node come first. So it will be deleted first. So whenever you are performing DQ operation, it is nothing but deleting the node from the beginning that you know already. So we can just simply write, let's say int result. Before fetching the result, what you can do is first to check whether the head is null or not. For example, let's say if the link, this particular queue is empty and you are performing the DQ operation, obviously you can't. So how we will know that that queue is empty? We can simply check the head pointer. If the head is null, it means the queue is empty. And in that case, simply you will say sysO queue is empty, something like this. And maybe you can return -1 from here. Otherwise, what we have to do, deleting a node from the linked list is nothing but first make the node as orphan node. So maybe what you can do, you can just store the, let's say, take a temporary node and store the head node in the temporary node. Now just write head equal to head dot next. Just move the head to next node. Maybe you can just store the result of the deleted node into the temp in the result variable, that is nothing but temp dot data. After this, you will just mark the temp dot next as null, breaking this link. Also, just mark the temp also as null. Decrease the size, maybe return the result. That's what we will do while deleting an element from the beginning in the linked list. Here you can see initially head is 1k. When you call the DQ operation here, what will happen? You will first break this particular link, move the head to the next location. Next location is 2k here. Head is updated to 2k. Update this link and mark this link as null. Then this link will break. Obviously, you can see that after breaking this particular link, this particular node is nothing but a orphan node. Whenever the garbage collector will come, it will delete the node if this particular node is not pointing to any other node and any other node is also not pointing to this particular node. This is how we will delete the data from the queue using linked list. Maybe you can implement the size as is empty function. So what I will do, I'll just quickly show you the implementation for, let me just open the Eclipse screen. I'll share the screen now. Let's say today's class is 33. We'll write the same thing here. Import java.util.star. Today's date is, I think, 16th or 17th of March. We will take one node here that is nothing but the head node. We will take the tail node as well. You can take one size variable also. Declare these nodes in the main function. Mark the head node as null, tail node as null, and size as equal to 0. Let's create the functions here. Maybe you can write public static void enqueue function. Put the data. Same thing you will do. You will create one node here. Put the data. Check whether the head node is null or not. If head equal to null, then in that case you will make the head node equal to tail node equal to the new node. Otherwise, you will just insert the node at the end of the linked list. For that, you will do something like this. Just write tail.next equal to that particular node and update the tail with this particular node. Once you will do this, you will increase the size. This is how you will implement the enqueue function. Let's say public static int dq function. If the queue is empty, it means the linked list is empty. When you will say the linked list is empty, when the head is equal to null, then we will say the linked list is empty. Then in that case, you will simply say system.out.println queue is empty. Return -1. Otherwise, in all other cases, what you will do, you will first put the node data, head data into result variable, that is nothing but header.data. Take one temporary node here which will store the head node. Then go to the next node, update the header node to head equal to head.next. Mark the temp node next equal to null. Update the temp also equal to null. Decrease the size. Return the result. That's it. This is how you will implement the DQ function. You can implement the isSize function or isEmpty function. Public static, let's say int. If you want to implement, you can implement it. The size function, size is nothing but you will return the actual size. So just return whatever size you have as of now. Maybe you can implement the isEmpty function also. Public static boolean isEmpty, and here you will write if the size is equal to 0, it will return 2, otherwise it will return false. Next function is nothing but equal to display function, public static void display You can traverse the node starting from the head node. How you will do it? Let's do that. Take one temporary node that points to the head node. Do something like this. While temp is not equal to null, print the node data, temporary node data first. System.out.println temp.data, then space, and after traversing this, just go to the next node, temp equal to temp.next. At the end, once you traverse everything, just print a new line. This is how you can implement your queue on queue using linked list. Here, maybe you can call the enqueue function. So let's call this particular function enqueue function. Let's say enqueue10, maybe enqueue20, maybe enqueue30. If at this particular point, if you want to print the size, system.out.println size of queue, you can simply call the size function. If you want to print the content of queue at this particular point, you can call the display function. Similarly, maybe you can call the dequeue function here. And after calling the dequeue function, again check the size and call the display function, whether it is working or not. Let's try to run it. If you run this, you can see that initially the size is queue, and you can see that the queue is nothing but 10, 20, 30. Once we perform the dequeue operation, 10, this particular node is deleted, and node will become 20 and 30, and size will become 2 here. So this is how we can implement our own linked list, dynamic linked list, dynamic queue using the linked list. Anyone has any doubt in any function, please let me know here.
दिला दिया। उसने असहाय होकर अपने कंधे उचकाए, तभी उसने धीरे से अपना दाहिना हाथ ऊपर उठाया। उसने अपनी हथेली खोली और उसके दिमाग में एक विचार आया। इसके तुरंत बाद एक पॉप की आवाज आई और उसकी हथेली से हल्के बैंगनी रंग की रोशनी का एक समूह था। लगभग
Please maintain the decorum of the class. Okay, if there is no doubt, then I think we can start with the new topic now. Let's call it as class 33 underscore 1. Here we will see how we can use the inbuilt Java class for using the queue data structure. Let's try to write the same thing here as well. Import java.util.star. Let's write the today's date, 17th of March. How we can implement or use the existing inbuilt queue data structure. To use that, you have to simply write queue. If you want to store the integer data, you will simply write integer. Let's say queue equal to, queue does not have its interface, so it will use linked list interface to implement the queue internally. Something like this. Maybe you can ask me one question. For example, in case of stack, we will write something like this, like write stack, let's say integer, st equal to new stack, something like this. In the right side, you can see stack is there. But in case of queue, there is no interface. That's why it will use the linked list interface to implement the queue. If you want to read about the documentation here, click on this particular queue. You will understand all the function here. Internally, they are also using the queue data structure only. Correct? Let's try to use few functions here. If you want to insert the data, you can call the add function here. Q.add, what it will do, it is nothing but the enqueue function. So simply you can insert 10 here. Maybe Q.add 20, something like this. Now, how we will know whether the 20 is deleted at the end or the beginning? So here in Q data structure, there is a peak function. Peak function is nothing but the element present at the front index. If you talk about the array implementation, or the element present at the head pointer, if you talk about the linked list implementation, that will give us the peak element. So here you can see that when we call the system.out.println, and if you print the peak element here, that is nothing but q.peak, then it will print 10 here, because 10 is nothing but the peak element at this particular point. How can I say that? See here, initially your queue is something like this. It will open from both the ends, you can see. Or maybe you can understand like this. Insert 10, then insert 20. Peak is nothing but the element present at the front index. So now if you print this, it will print 10 here. You can just test this. Just try to save this program. Let's try to run it now. Here you can see that the peak element is nothing but the 10 here. It means 20 is inserted at the end. Obviously, that's why you can see 10 as the result in the peak. Also, if you insert one more element, we can print the peak element after inserting every element. For example, we inserted 10, then we'll print the peak. Then we inserted 20, we'll print the peak. Maybe now we can insert 30, and then also we will try to print the peak. Every time we will see peak will be 10 only, because that is nothing but the element present at the front index. You will see this every time the peak is 10. This is how you can add the element into the queue. If you want to print the size, let's say system.out.println queue size. There is one function here that will give you how many elements are present at this particular instance in the queue. Similarly, there is one function to check whether the queue is empty or not. Let's call that particular function before adding any element. Let's say queue empty, and you can just call one function here which we implemented. It is also similar only. Queue dot is empty. It will just check whether the queue is empty or not. So here at the end, maybe you can just see if there are no element, then it will return true. If there are element in the queue, it will return false. So initially you can see queue is empty. It is returning true. After inserting 3 elements, the size is 3, and queue empty is nothing but equal to false. Now the next function is, maybe you can just write queue dot. Here is one function to delete the element, that is called as remove here. You can just remove the element from the queue like this. Which element it will remove? Automatically it will remove the element present at the front index or the element present at the head pointer. So here you can see 10 will be deleted now. Now if you see the peak now, peak will be changed and it will print 20 here, because after 10 the new peak is nothing but 20. And if you see the size also, then it will be, you can see size is also reduced now. And it will point to here. See here, after deleting that particular element, the new peak is 20 and queue size is now 2. These are the functions that you can internally use to use the queue data structure. More or less, we already discussed how these methods are implemented internally. If you want to know, or if you want to go in little bit detailed manner, then I think you can just refer this add function and all. If you refer this add function, then you will get to know what is happening here. Correct? So these are the remove, poll, and peak functions here. Correct? Now, if anyone has any doubt, please let me know. Otherwise, we'll start with the questions now. Okay. Seems like there are no questions. So we will start with questions on linked list data structure. I'm sharing the whiteboard now. Let's discuss the questions one by one. First question. Implement stack data structure using queue. Now, whenever someone saying implement stack using queue data structure, what is the meaning here? Stack means what? Majorly there are these operations in the stack. You have to implement the push function, pop function, size function, is empty function, or maybe in case of stack you have top pointer. So these things we have to implement using queue data structure. We already discussed how to implement the stack using array data structure, how to implement the stack using linked list data structure. But now we have to implement the stack using queue data structure. So whenever we will write the push and pop function, in those function, we will try to use the queue data structure. And using the queue data structure only, we have to implement this in order of one time. What is the challenge here? If you see, I will give this particular question as an homework. Try to think about it. But first, I will explain you what are the challenges here. For example, if you use one queue here, correct? Let's say in case of push function, you just simply insert the data into the queue. When you call, let's say push 10, you are inserting the data into the queue, something like this. Maybe let's say push 20, you will just put something like this. Then push 30, you will push something like this. But whenever you will call the pop function, ideally what will happen? In a pop function, stack functionality is nothing but the element which is inserted at the end. The element which is inserted at the last will be deleted first. Last come first in. So pop function ideally will return what? 30. But if you implement this particular with queue data structure, when you call the dequeue function, then 10 will be removed, but we want 30. That's the problem here. That's the challenge here. So what's the algorithm here? You have to implement the stack using queue. These are the challenges. You can see if you directly apply the dequeue function, dequeue will delete 10, but we want 30. Now how we will do it? This is the assignment question. In this case, what is the expected time complexity? Maybe you can implement the push function in order of one time and the pop function in order of n time. This is one acceptable time complexity for push and pop function. The second one is maybe you can implement the push function in order of n time and implement the pop function in order of one time. This is second. You can choose anyone. If you want to make the push efficient, go with this particular approach, make the push in order of one and pop in order of n. If you want to make pop efficient, then make the pop as order of one and push in order of n. Less than order of n is not possible. At least either we will go with order of n in case of push or in case of pop, but not in both cases. Anyone has any doubt in this particular question, please let me know.
No, sir.
Okay. Let's go to the next question now. Before moving to the next question, I will give one clue here. To implement the stack, we need two queue data structure. This is the clue, or you can call as hint. Use two queue here. How you will use it, that you have to think. But this is how we can implement the stack, making the push efficient or pop efficient. Second question. Question number 2. Same question. Implement stack using single queue. Now here they are restricting that you have to use only one queue. And using that queue only you have to implement the stack, push and pop functions. The restriction is you have to use only one queue. I'll give you the hint here. Try to think about recursion here. This is the second question that you have to try. Anyone has any doubt in this question? This is a little bit hard. The question one is little bit easy. Let's move to the third question. Third is the easy question only. You are given a queue. Example, let's say you are given one queue here. Let's say queue equal to 10, 5, 10, 20, something like this. This queue is given to you. What you have to do, you have to reverse the queue. So this is the expected input. What is the expected output? It is nothing but reverse of this one, 20, 10, 5 and 10. Initially the queue is 10, 5, 10, 20. It is something like this. This is the queue, 10, 5, 10 and 20 initially. But after you reverse the queue, then the queue will become 20, 10, 5 and 10. Anyone has any doubt in this particular question, please let me know.
No, sir.
Question number 3 is very easy. It's not that hard. Question number 1 is medium level question and question number 2 is hard level question. Think about these 3 questions. If you have any doubt, ask me in the next class. But please submit these questions before next Saturday. Let's go to the next question. In any data structure, if your basics are strong, you can handle these questions. It will take some time to think about that particular logic, but you can do it. If your basics are strong, you can do it. That's why I covered the queue data structure. Like first I implement the queue using an array. Then I show you what is the problem there. Then we move to the circular queue approach there. Then there is a problem there that we can't increase the size. We have to implement the dynamic queue. For that we use the linked list. If you have the understanding of these two things, then you can do these questions easily. Also, in first class only, if I explain about the inbuilt function, let's say add is doing this, delete is doing this, then you will not get the complete clarity. That's why before explaining the inbuilt thing, we are learning the basic implementation of queue. Now let's try to move to the next question. Question number 4. You have to generate numbers with given digit, and the given digit are nothing but 5 and 6 in increasing order. So with digit 5 and 6, you can see that the first number possible is nothing but 5. The second number is 6. Third number is 55. Fourth number is 56. Fifth is 65. Sixth is 66. Then 555, 556, 565, 566, followed by 655, 656. So you have to generate numbers with the given digit. How many numbers you will generate? Maybe that is given to you. Let's say input is nothing but you have to generate first 10 numbers with these digits. That can be possible. So here you can see that the first 10 number are nothing but till here, I think. Till here. These are the first 10 number. So expected output will be 5, 6, 55, 56, 65, 66, 555, 556, 565, and 566. This is the output here. What is the input? Digit is given as an input, and how many numbers you have to print, that is also given as an input. Any doubts here in this question as well?
No, sir.
No, sir.
So try
No.
these 4 questions. I'll just share these 4 questions with you. I can discuss these questions today also, but I want you guys first to try, just give one attempt at least, because in queue we have less questions. I think there is only 1 or 2 questions left in the queue data sector. Rest are basics only. Basics we already covered. So just give one attempt. Then we will discuss these questions in the next class. So I will share today's code and these 4 assignment questions with you. Maybe by tomorrow you will get these questions. Please try these questions and let me know.
Okay.
Yes,
Let me
sir.
just share the code first on the group. From next week, we will try to start the tree data structure. But before starting the tree data structure, I want you guys to revise the linked list stack and queue concept. Also revise the recursion again, because in queue, in tree data structure, you will see lot of recursion is getting used. Let me just share the code. I shared all the assignment questions with you. Let me know if you face any difficulty. You can ping me directly on Slack. I'll help you out if you face any difficulty. Thank you everyone for joining the class on time. We will meet
Thank you,
in the
sir.
next class. Bye. Good night.
Thank you, sir.
Thank you, sir. Good night, sir.